so this is objective 1. We will label our notes objective 1, objective 2, objective 3, objective 4, those that I had in 8th grade or even in algebra 2. You know, y'all thought y'all were getting away. Yes, no more objectives. And here we are, back to square one. What's an objective, by the way? It's a goal. It's what you hope to achieve. So our goal for today, that's how we label our notes, okay? Instead of labeling, you can put the date on them if you want to put the date on them. But that way, you know, if we're taking notes and you have 1, 2, 3, and 5, you know that you're missing number 4, and you need to go back and get number 4. So our goal for today is we are going to correctly factor polynomials. Tell me, what are some ways to factor? GCF, the reverse of FOIL, like trinomials. Difference of squares, and then difference of cubes. Do we have a sum of either of those? You can do a sum of cubes. You can do a difference or a sum. Squares, you can only do a difference. And when I say difference, I mean subtract. It's got to be subtraction. You cannot do a sum of squares. Okay, so here are your ways to factor. I think you got them all. There is one. I don't think I go back and forth whether I show this way or whether I don't show this way. Those that I had in Algebra 2 last semester, I didn't even talk about it. I might have talked about it last spring. I can't remember. I am going to do one example with grouping just to show you that there is another way. That's just, you don't use that way a whole lot. You don't group a whole lot. GCF, difference of 2 square, trinomials, which is your FOIL, sum and difference of cubes, and your grouping. If I go too quick, you let me know. I will tell you on tonight's video, you know, someone mentioned in here they like the videos because they're straight, they're to the point, and they're quick. You're probably going to have to use the pause button and pause each slide just so you have time to write it down. I didn't give you much time. Like, I just kind of read through it and then rolled right on through it. Okay, so get in the habit of using your pause button with it. And I will tell you too, like, when I encourage you in the video, like, hit the pause button, try it on your own, see if you can do it. If all you do is like play it and copy it, you're not really thinking about it. That's the only difference. I'm going to pause for just a second. All right, so let's look at the first example. Okay, we're just going to kind of work our way through. What do you always look for first? GCF. Okay, so here's my question. I see some GCFs. What could we take out of the first one? 7. You can take out an a squared. This has 3 a's. This has 2 a's. This has 2 a's. So what's the largest amount I could take from each? I could take 2 a's. I could take an a squared. And what else? B cubed. This has 3 b's. This has 4 b's. This has 3. The largest, you could take 3 away from each. And c. You can take a c out of each. So I'm going to take out a 7, an a squared, a b cubed, and a c. Did I get that right? 3 blanks. Why 3 blanks? Because it's a trinomial. There's 3 terms. You got to put something in each of the blanks. So if I divide out a 7a squared b cubed c, what will I have left? 2a. Is that it? Okay. Minus 3b plus 1. Very good. And you got to have that 1. Okay. If you don't have that 1, it's not going to work. What's a good way? I'm not going to make you check your trig. You know whether or not you need to check or you don't need to check. Certain things I will make you check, but, you know, just basic factoring, I'm not going to make you check. But what is a good way? If you're unsure, what's a good way to check yourself? Justin? Yeah, you can just distribute it back in and make sure that you get your question. Okay? My question is, this is a trinomial. Can it go further? You know trinomials that can go further because they kind of look a certain way. Like normally they start with a degree of 2 and then go to a degree of 1 and then have a degree of 0. Like it'll look something like this. When I say degree, I mean exponent of 2. X squared plus, I don't know, 8x plus 15. Degree of 2, degree of 1, degree of 0. Or it might even be a degree of 4, then a degree of 2, and then a degree of 0. But you can tell this right here that there's nothing that when you work it, you're going to get just a B, especially if you have an A in the front. It's just not going to work. Okay. All right, so example 2, what do we have? What can I take out? A 3x squared. And what would I be left with? 2x squared minus 4x plus 1. Now this trinomial, degree of 2, degree of 1, degree of 0, could it go further? Try it. Go for it. You just said yes. Like what would multiply to be 2x squared? 2x and 1x, and then what would multiply to be 1? 1 and 1, that's your only options, right? So it'd have to be that, and it'd have to be what signs? 2 minus. So my question, will that give you 4 in the middle? No. So it looks like it can factor, but you realize not every trinomial is factorable. You know, you're going to have to try it. You're going to have to see if it works, but it doesn't work. Okay? Everybody okay? Wiping the dust off? All right, let's roll on. You want me to give you a second to kind of roll through them? What kind of factoring is this? Are they, okay, squares. What do we know about squares? What did I just say in the beginning? You can only do a difference. So maybe I should hit example 5 up first. You know the number one mistake people do with example 5? What do? They do x plus 4 and they do x plus 4. Or they do x plus 4 and x minus 4 and then they assume it works. But my question is, that looks like it works. But if you fold this back together, that would be x squared. This would be 4x. This would be 4x. What's the issue? You get, those don't cancel. Like you're looking for a difference of two squares, you're looking for two that cancel in the middle. And that doesn't work. Does everybody understand that? That doesn't work. And you can sit there, you can flip the signs around, you could do two negatives. You're going to get negative 8x in the middle. You could do one positive, one negative, like a difference of two squares. What will happen is that the middles will cancel, but you'll get a negative 16 on it. It's just not going to work. So what can you say about example 5? Yeah, you can just say not factorable. Whoops. You can say not factorable or you can say prime. Okay, so I do want you to know you can only do a difference of two squares. You can only do a difference of two squares. You cannot do a sum. So maybe I'll work backwards. What should it factor into? X minus 5, x plus 5. Everybody good with that? And these are the easiest ones because you just use their square roots. Like, is there an option for you to ever use 21 and 25 and 1? No. With squares, you use their square roots when you factor them. Okay? And you can foil that out and you can see. Like I said, if you're like, I'm super lost and I don't remember a word of this, you may need to go back to an Algebra 2 video or even an Algebra 1 video and kind of refresh your memory on how to do this stuff. Okay? All right. How about example 3? 3x minus 8 and 3x plus 8. Any questions on that? Everybody's good? All right. All right, so let's get into cubes. Okay. Cubes, you use the formula. So I've provided the formula there for you. And I'll give you a second to write that down, and then we'll take a look at some and apply. All right. So really easily, And I don't recommend this. I don't ever recommend going straight from question to answer. I mean, if you get really good at them, you probably could. But as you're reviewing, as you don't remember, it's a three-step process. Step one, write your formula. So what would our formula be for this one? If it's a minus here, what's it going to start with? A minus B times quantity of, and then switch the sign, plus AB, and then B squared's always positive. Step two, we're going to define A and B. How do I get what A and B are? You take the cube root of each of these. So the cube root of 8x cubed is 2x, and then the cube root of 27 is 3. And then from there, all you got to do is plug it into the formula. So my A is 2x minus 3 times quantity of square the 2x, that means you got to square both, 4x squared, plus multiply them together, 6x, and then square the b, 9. And I know this looks like it can factor further, but it cannot. Cubes will remain how they are in the formula, so you won't have to go further with them. Any questions about that? So how about you try example 10 using that method, and I'll give you a helpful hint. What's the cube root of 343? I know you don't have a calculator yet. 7. 7. Cube root of 343 is 7. What's the cube root of 64? You gotta be careful, because people look at 64 and they automatically think square root. They think 8, but it's just 4. Cube root 4 times 4 times 4. So cube root of 64 is 4. So what would my formula be? Ah. A plus B, A squared minus AB, B squared. Any questions on that? Okay. Let's define A and B. That's very important. So what's the cube root of 64y cubed? 4y. And then what's the cube root of 343z cubed? 7z. So now we're just going to plug in. So this should be 4y plus 7z. When I square the 4 and the y, I'm going to have 16y squared. I'm going to multiply them, so minus 28 yz. Why do I say yz? Alphabetical, generally alphabetical. And then I'm going to square the b squared, and so that would be 49z squared. Thumbs up if you got it right. Good, good, good. Any questions? Y'all let me know if I'm going too fast, too slow. Like, I'm going at this assuming that you have, like, we've done this before. Question? Did I skip from 5 to 9? Oops. I'll go back. Thank you. What else? Yes. Yes. You would have to take it. Always take a GCF out first. Does that make sense? And I would recognize, well, I was going to say, I'd recognize 8 is not a cube, but it's a cube too. So yeah, you would take a GCF out first, and then it would probably still be cubes at the end. All right, let me see if I can find 5. 5, maybe it's backwards. Maybe I just took them out. Maybe it's misnumbered. All right, so let's fix it really quickly, and I'll have to make note of it. So this should be what? 5. This should be 6. This should be 7, and I apologize. And then this will be 8, 9, 10. And that's good news for us, because then we don't have quite 17. So sorry about that. I will have to tell you, these are, because I only had one trig class before, that was a first draft of a PowerPoint, so there are probably going to be some typos in it, and then I just have to fix them. along the way. So I do apologize for that. All right. So we've done GCF. We've done difference of two squares. We've done cubes. On to trinomials. So trinomials just work the reverse of FOIL. So when I factor trinomials, they go into two binomials. First times first will be what? A times A. Last times last is going to be equal to what number? Like, what are we working towards? What is your last? It works to, I always used to tell my 8th graders, multiply to be the last, add to be the middle. And that's what they repeated after me. Multiply to be the last, add to be the middle. Okay? So we're multiplying to be negative 42, and then the outer and the inner are going to add to be positive 1. What do we think? Negative 6, positive 7. Any questions? Does everybody, do I need to FOIL it out and show you how it all works together? Because if you're not understanding where I'm at, that's going to be an issue. When you do, I'm just going to do one. When you FOIL this, this will be a squared. That will be 7a. The inner will be negative 6a. And then negative 42. And then you add those and you get a positive 1a in the middle. Okay? And that's how that works. Okay, any questions on that? All right, I'm going to give you a second to look at 9 and 10. All right. Owen, pick one. It doesn't matter whether it's, we can start with either one. Which one you want to start with and tell me what you know. You can do example 9 or example 10. Okay. So I'll break it. Do all trinomials, for the most part, break down into two binomials? Yes. So you'll make your two binomials. What do you know about it? Okay, 2a and a. Okay. What about the last? They're both plus. Okay. You're off the hook. Let's go to Gonzalo. What do you think is going to go in the last part? Okay. So my question is, this number times this number is going to give me which of these pieces? Last times last always gives me this number right there. So my question is what times what is 3? 3 and 1. So we know we're going to be using 3 and 1. Okay? Anybody have any thoughts as to which one goes where? Which one goes here? 3 goes here. 1 goes there. And this is a trial and error method. There's no way to figure that out. You just got to go ahead and, you know it needs to be 3 and 1, so try it. And then what you do is you check your outer and your inner. What's my outer make? 2a. What's my inner make? And when I add them together, I'm going to get 5. Okay? You've got to understand that first times first is going to give me the first piece. You need to know that that times that gives me the first piece. You need to understand that last times last is going to give me this last piece, and that when I do the outer and the inner, that makes the middle. You've got to understand that. Okay? That's very, very important. All right. How about the last one? That one should be a little bit easier. X and X and what and what? Minus 5, sorry, it won't write, plus 3. Sort of. Like, would it be okay if I put the plus 3 in the front and the minus 5 at the end? Would that be okay? What property tells me that's all right? Commutative. Commutative says that 3 times 5 is the same thing as 5 times 3. Okay? X minus 5 times X plus 3 is the same thing as X plus 3 times X minus 5. So that does not matter. But what if you just did this? What if you just put the 3 here and the 5 there, and it was a minus 3 and a plus 5? Would that work? No. So if you switch it around, it's got to have the correct sign. Okay? Any questions on that? All right. So I do want to cover grouping. How many remember grouping? So I got a couple that have seen it. And I, like I said, sometimes I teach it and sometimes I don't. I kind of looked at it today and I was like, do I want to go over this? And I'm like, well, you know, if you're moving on up, it is nice to know that this is a possibility. You just don't use this a whole lot. Okay? Grouping is used with 4 terms specifically. Okay? When you group, you have 4 terms. What we're going to do is we're going to group the 2 in the front and 2 in the back. And we're going to take out a GCF. Okay, if I take out, what can I take out from the first one? Be more specific. 2x. And I'd be left with 5a minus y. Okay? What can I take out from the second one? A 3b. And specifically, I need to take out a negative 3b. You know why I need to take out a negative? Because look at my signs here. I have a positive and then a negative. Here I have a negative and then a positive. And I'm going to need to make sure that they match. So I've got to take out a negative 3b. Because when I take out a negative and a 3 and a b, I'll be left with positive 5a. Does everybody understand that? And then it's going to match with this 5a right here. Okay? And when I take out a negative from this positive, what will that make? It'll make a negative. It makes it switch signs. And you'll have a negative y. And so now your groups match. Okay? So what I say is, I used to call this like gumbo soup or whatever. Like you kind of, or vegetable soup, like on snow days and you want to make vegetable soup. What does your grandma or grandpa or mom or dad or whoever go and do? Like it's a blizzard outside. You can't go to the grocery store. So what do you do to make vegetable soup? You go to the cabinet and you look at what you got and you throw it all in a pot. Like sometimes my vegetable soup has green beans and corn and okra in it, and then sometimes my vegetable soup has carrots and potatoes and lima beans in it. You follow me on that? No? Not at all? Okay. No soup. Okay. So ixnay on the analogies. All right, so here's what I will say is another way to write this. If 2x is being multiplied by 5a minus y, and negative 3b is being multiplied by 5a minus y, a shorter way to write that is to put these two pieces together and say 2x minus 3b. Both of them are being multiplied by what? 5a minus y. Because what do you end up doing when you full it? You end up taking the 2x to the 5a and the minus y, and then you end up taking the negative 3b to each. So that's just a shorter way to write it. The groups will match. Yep, with grouping. Okay. So I just kind of wanted to, like I said, you don't use this way a whole lot. Actually, in our practice, I don't think any of them are grouping. I just wanted to kind of expose you to it, just to say you've seen it, and it is possible that it may come around somewhere along the way. What I want to do is, I'm sure your question is yes, Ms. Corns, we've been doing this, you know, we've been factoring for years and years and years. How is this going to take us to the next level? And trig being your next level. So on each of the next couple days lessons is I'm just going to kind of introduce you a little bit to how we're going to be using our factoring skills once we really get into trig. Okay? So we have sine squared x minus cosine squared x. If I wanted to factor this, do you have a thought? You can't take out an x because the x is part of the, like cosine of x is like cosine of x. Does that make sense? So you're thinking, what other kind of factoring might it be? Okay, so I would say that this is a difference of two squares. So what can we factor sine squared x into? Sine of x times sine of x would be sine squared of x. Do you understand? It'd be two of them. So it'd be like, how do you factor x squared? X and x. Okay, so sine of x squared, or sine squared of x, you would say sine of x times sine of x. What will my signs be? 1 plus, 1 minus, because you need them to cancel. And then, how would you factor cosine squared x? Cosine of x times the cosine of x. And that's how you would factor that. Did that blow your minds? Treat like sine squared x the same way you would treat like a variable squared. Does that make sense? You treat it the exact same way. Okay? All right. How do you think we're going to factor this one? Like a trinomial. So let me do this so I don't get fussed at. Let me take attendance really quick. Let me give you like, I think this is our last example. Let me give you like a minute and a half. Try it out. It's like a trinomial. See what you can do with it. Talk about it with your neighbors, and I'll get back to you. All right. We know trinomials break into, come on, right on the board for me. Two binomials. This is not the one I want. All right. What do you think? Sine of x and sine of x. And what and what? Positive 1 minus 7. And let me just show you how this works out. How many were able to get that? Like how many were able? So it's not that hard. You just kind of have to train your eyeball to be comfortable working with sine, cosine, and tangent. Okay? So if you fold this, what's sine of x times sine of x? Yeah, and properly you just say sine squared of x instead of sine of x squared. It's just the way you write it, okay? It means the same thing. There's two of them, sine squared of x, okay? What's sine of x times negative 7? Negative 7 sine of x. What's 1 times the sine of x? Plus 1 sine of x, or plus, you can put a 1 there if that helps you, okay? And then 1 times negative 7 is negative 7, and these are like terms, so you can add them together and get negative 6 sine of x in the middle. Not so hard, okay? All right, I promised that was the last one, but this is the last one, I promise. What do you think? Like, I want you to think, remember how I said treat this like, so this first part, if I just treated it like an x, it would be what? X cubed plus what? X. So what would you say? Take out a GCF, take out a x. So what am I going to take out here? I'm going to take out 1 tangent of x. And what would I be left with? Tangent squared x plus 1. Those look like perfect squares to me. Can that factor? No, because it's the sum and you could only do a difference of two squares. So I'd say that's all you can do. Okay, any questions on kind of just giving you, slowly by slowly, I'm going to give you a little more glimpse of how we're going to be using our skills once we get into trig. Okay?